With the launch sequence complete, we're now ready to move on to do the media process. Now the media process is a two-stage test. The first stage is to render the project you see before you, which is called the Game Anime project. Now the purpose of this test is to get the confidence that the video editor produces an MPEG-4 file that conforms to my requirements and the standards. Now if you want to know what those requirements are, hit the requirements tab before you continue. If it completes successfully this test, then I will make it do the Game Anime test. And now the Game Anime rendering is that project you saw me load right in the launch sequence. The added thing with Movie Edit Pro is this is the editor that's used as a baseline to reference the performance of the others. So with this baseline on that, let's go through this screen because it's a very busy screen. What we have here are lots of monitor applications to help me see how well the video editor utilizes the platform it's running on. Now we've got an i7 and this is the CPU monitor for that. Now the i7 is a quad core. Each core has two threads. A thread is known as a logical CPU. So what I'll be looking for here is the workload evenly balanced across all these logical CPU threads. So that covers the actual CPU. These are sensors throughout the platform itself, which I will bring out some of those into graphs, and one of the graphs is this one here. This gives me the total CPU usage, which is effectively these logical threads combined. This graph here gives me what is the CPU load, what is the actual loading on that CPU. So with the two together I can get a good idea what's going on. The executive test dashboard is used to tell me if any bottlenecks occur and what was the cause of the bottleneck, what was loading onto the CPU at the time, and let's not forget the star of the show is the actual editor itself. So that explains the screen and all the monitors that you are seeing. Now let's go through the media process, which is this very busy dialog box. Now if you just hit the drop down box, you'll get lots of presets. These are filtered ones relevant to the project you're on, but if you hit display all, then all the presets as supplied by Magix and your custom ones will be shown. So I'm going to show you how to create your own. So pick standard. I now need to tweak it. First I need to get the screen resolution correct and the frame rate. And as you can see, each time I select something, that format description changes. But I now need to do a deep dive, and to do that you hit the advanced button. Now this dialog is three sections. The video codec is the video stream, audio codec for the audio stream, and this multiplexer is the actual container. And you can select streamable format here, which is one of my requirements, and some don't even let you do this. This is a first, so that's nice to see. And the other one is you can elect to go hardware acceleration or not. So what I'm going to do is go through this now. Let's go to the audio. You've got a complete range you can pick, and now it's always best to pick the same audio rate that you captured at, which is in my case 256. So let's move on to the video editor. Now the first section here is if you want to do a software only or GPP, or do you want to use the hardware accelerators. This section here is important and part of the requirements. This determines the profile and level, and this determines the constraints that you want to put on the video player. This section here is your data rate, which is very important. This tells you how hard or aggressive you want to compress your project to a MPEG-4 file. Another factor that determines not only the quality but also the file size is the GOP structure, and I'll go into all those three sections in more detail in a few minutes. And last but not least is a section where you really do need software tools to make best use of, and that's the statistics area. So let's go to the generic, which is about the constraints you want to impose on both the encoder and on the player. If you're going to do 1080p, you really do need to have the profile suited for that. Now 1080p and broadcasting, that requires high, and if you're doing the internet, that also means you are broadcasting. Now this section here is quite important. If you're going to want to compress and use B frames, you need certain amount of time to do that. The more time you have, the higher the quality, and that's what this is about. So in short, that means if you want to create a high quality product and a smaller file, then you need to use B-frames and you need to be at best quality. But if you want to balance between the time it takes and the quality, then you really want to go for what it calls balanced. So that explained very briefly. I picked high quality. Now the GOP structure is very important because again this impacts that performance, so you really do need to have your B-frames on if you want to get some kind of lower compression at the same time if you want some quality. So I'm going to put this to 3. The other variable you want to set is the GOP length, which is group of pictures length. This all this means is the first frame is uncompressed. When should the next uncompressed frame be? And I'm saying 30 frames apart. So with that set, we're now ready to go into the variable bitrate. Now if you're going to have a movie which is watching paint dry, then you would pick constant bitrate. But if you're a gamer or anyone else that you've got some activity in your movie, then you really do want to pick variable bitrate. This gives you the best optimal compression as well as the best sort of quality. Now I'm picking single pass, but if you've got variable bitrate, you should go for double. Now the other first thing, the unique thing about this particular editor is the HRD. You can actually select this. Now the HRD is very important. Just view this as a proofreader. How many people would create a document for others to read that they wouldn't like someone to proofread to make sure A, the spelling is correct, and B, the grammar is correct. Now in the sense of a movie clip, this is what the HRD does. It makes sure that the movie you're creating or encoding can actually be playable by a player and the buffers don't get overflow or underflow. Now this section here is talking about the max bit, the average bit rate. Now this becomes redundant if you're going to set the HRD properly. What is important is the rate you feed the buffer. Now the buffer is known as the coded picture buffer and the rate you feed it is known as the HSS. So I've picked 8. And the coded picture buffer is the size of the buffer that you want to have with where those coded pictures will come in, so the player then can start to decode. And this buffer is also that size where those B frames are. So all of this should be set up. Now if you set this up correctly, you'll get a high quality product that you can almost guarantee will be playable to any player. That completes the HRD section. Now the advanced section is really for those people who are confident and fully conversant with H.264 and what they want and believe what they will get. Otherwise you might not get the result you were hoping for if you tweak this. Once you've done all your tweaks, you get the format description here, and as you can see I'm going to do the software or GPP first time. So my first run is going to be software only. The directory it's going to go to is here, and away we go once I pick rendering. Now the biometric scanner being only 16 seconds long is fast. Now software only 21 seconds is a very good time, and that's the time I expect now as a reference to other video editors that use software only. This is now going to use QuickSync. It doesn't use the HD 4000 graphics system completely because it's only up to version 3, but this did it in 16 seconds. So any QuickSync type encoding I expect in and around 16 seconds. So let's see what sort of time I would expect for a CUDA based device or a CUDA option. And the answer to that is 30 seconds. 29 seconds is the elapsed time, but if you look at that remaining time, 1 second, that is 1 second worth of IO operations or IOPS, so 30 seconds. So we now got reference times for the 3 types of options I can do on this platform. So it's now time to analyze the actual MPEG-4 file. Now all 3 of these options came up with a similar result. So the first thing is the container must be streamable. Now the reason why it must be streamable is if you're Going over the internet, a streamable file gives you smoother playback, and it's nothing to do with broadband. The HRD data being present is very important, because if you're a freelancer and you want to have proof that the quality of your product is there and is playable, there you've got it. Now the blue square shows the efficiency, how well the editor used the resources of the platform. Now, as this is the reference, it's got to be the base level for all of them. But you've got to look at it from this point of view. It doesn't matter if you're doing something for free on YouTube or if you're a freelancer. It costs you money to actually produce these videos, and the more you produce, the more money it's going to cost you, and this running cost could exceed the cost of a cheap editor. So look at it from this point of view. If you can keep this down and you can keep this efficient, you're making more profit, be it from money or revenue you're gaining from YouTube through adverts, or be it because you're a freelancer and you're charging for a product. So these are quite important things to bear in mind as to what it is you want to do with your media. Now, a mediapreneur is a person who wants to make money, and you're not going to make money if it costs you a lot to actually build the file. And game animes can take many hours when it should only take one. And some of these you'll see through the media processes of the other editors can take a lot longer. So bear in mind this, that it's quite important to be efficient as well. So we're now ready to do the game anime itself. Before I go any further, just as a reminder, these are the monitors, and this one here is used to tell me if any bottlenecks are created and what caused that bottleneck. A new monitor is this one here, which is effectively the process space of the Movie Edit Pro editor, and this is going to tell me what resources are consumed during this rendering process. This is Process Explorer itself, and this can tell me the total resources consumed by the platform. Using the two, I can get an accurate idea of the resources consumed during a rendering process of the editor. That concludes all the monitors that I've got visible. There are many more, but let's just leave it at this. The export dialog shows that I've opted to use the quick sync because this was shown to be the most efficient for this platform. I want to use this, and I should be expecting to see a low, evenly balanced load on the logical CPUs between 40 to 50%, and I should be hitting hard the HD 4000. So there's my predictions, and yes, they marry what I expect to see. What I do like about this process is this dialog gives me an idea that it's actually doing the job. What I didn't like or didn't expect was to see this. Now, it turned out that Movie Edit Pro 2014 could not make a game anime anything larger than 30 minutes, and it went wrong, as you could see. Now, I got in touch with technical support. Within 24 hours, they got back from monitoring and watching my video. Within 1 month, they put out a solution for everyone as an upgrade, and it sort of worked, but it was not good enough. So I continued to tweak with the process, the media process dialog. Now, bearing in mind their media process dialog, that export dialog, it's the only one of its kind. I couldn't have done this without A, the support from technical support and the work they had done, and B, this kind of process. I even download Total Code, which is from Main Concept, to get an idea about the encoder to see if I can get this process done right. So what you're about to see is that process, thanks to technical support and thanks to the fact that they got a good media process. But before I do that, 2015, there is no issue. So this is my first run, and most people would be happy with this. You'll see waveforms similar to this from the other editors, but I wasn't. I wanted to do more tweaks because that's the engineer in me. I wanted to see if I could make it better. As I said before, Total Code was a good thing for me to go into because it gave me an idea of what the encoder is truly capable of and what would be the best values. And when I did do that, this is the profile that I really do like, and you should see it. It's pucker, it's smooth, the buffers behaved
perfectly, and there are not many video editors that can do that. So that's really good, and that's my point about main concept. It is capable of doing the job. So this is a 5-star process, and that all those stars belong to technical support. The great support I got from them, I can't praise them enough. It made me feel and drove me, motivated me to actually solve the problem. And it deserves the red ribbon, because the 2014 couldn't have the blue ribbon, which is first place, due to the fact that you can't actually get it to still work properly without doing these excessive tweaks. 2015 is a different matter altogether. It doesn't need these tweaks, and it does do the job. What I can say is, if it weren't for technical support, it wouldn't even get anything, because it couldn't do the job. So good job, well done, technical support from Magix.